Today's question is maximum number of visible points. Let us see what is the question. So we are given with an array of points, an integer angle and your location. So this is an array and then we have an angle and location. Location is also an array which contains position of x, position of y. So these are coordinates, x coordinate and y coordinate. And points is also an array of such points where the first part of the array says xi and then yi. So this is quite clear. Both denote integral coordinates on the xy plane. Initially you are facing directly east from your position. You cannot move from your position, but you can rotate. So we are at some position and we are looking at east direction. We cannot move from this position and we can rotate. Rotation is allowed. In other words, position x and position y cannot be changed. Your field of view in decrease is represented by angle. So at one point in time, the thing that is visible to us is going to be defined by a certain angle, and this angle is given in the question. So degrees is represented by angle. Determining how wide you can see from any given view direction. Let d be the amount in degrees that you can rotate counterclockwise. Then your field of view is the inclusive range of angles this and this. Yeah, obviously. So once we move in certain direction, then our view also changes. So let's say that we moved here, so our view changed from this to this. Yeah, that makes sense. So what do we need to find here? You can see some set of points. If for each point the angle formed by the point, your position, and the immediate east direction from your position is in your field of view, right? So yeah, we are looking here. This is the angle that is given. We move in this direction, so our field of view also changes, right? So there can be multiple points at one coordinate. There may be points at your location, and you can always see these points regardless of your location. Rotation. Points do not obstruct your vision to other points. So we need to return the maximum number of points you can see. So let us see from this example. This is our location. Our location cannot change. But what we are seeing here is in our current field of view, there are 3 points, right? So 3 would be answered in this particular case. Let us take a few more examples. So let us say this is the graph that we are given with. And there are some points on this graph. Here, 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 here. And this is the location that we are given with. Now there could be more points at our location itself, and this point, whatever points are there on our location itself, are always going to be visible, right? So that is always going to be a part of our answer. Let's say there is 1 point. So we know for sure that at least 1 point is going to be visible, always visible. So the answer would be 1 plus something. Now let's say that this is the angle that we are given with. Let us call it angle. And then and we are free to move this angle anywhere. So this can change. This can change. This was not a good rotation. This should have happened well. So let us say that this changes, and this changes from this point particularly. And the new angle that it makes would be this one. Something like this. And well, it is not clear here, but the angle that it is making, we are assuming here that it is going to be the same. So in this case, there is just one point which is visible in our field of view, and in this case there are 2 points which are there in our field of view. So our answer is going to be 2 plus 1 that we got from this. So the answer is going to be 3. So as it seems, it feels like a sliding window question where we need to change our direction of view. We have to rotate, and in whichever direction we find the most amounts of points, that is going to be our answer. And it seems like there is some mathematical background also needed here, because there are angles and we'll probably need to calculate angles or do some calculation over these comparisons over these angles. So we should probably understand some basics of from our elementary mathematics as well. So let me see if I can tell you something. So let's say that we are given with this point and this point. This is our graph. So this is 0, 0. And this is another point that is going to act as a reference for us. So let's call it 1, 2. This is also 1 and 2. And well, just to make sure that we are at a nice place, let me make this here. 3. So we need to find out this angle, this angle. So the first step in our algorithm is going to be sorting all the points according to the angles that they are making with the x-axis. And obviously, if we want to sort something according to their angles, we need to understand what is the angle that they are making with the x-axis, right? And this is going to be with taking a reference from this particular point that we are given with location. So here, the coordinates of this particular point are going to be 3, 2. This point is going to be 2, 2, and this particular point is going to be 2, 1. So we need to find out this angle, and then we have to find out this angle. And if theta is going to be smaller than theta dash, then this point will appear before this point in the list that we are going to sort. So how to find this theta? This is where some mathematical background comes into the picture. So from your mathematical classes back in the days, would you remember that if there is a triangle, this is hypotenuse, this is opposite side, and this is the base, or we call it adjacent side. So tan of theta is equal to O divided by A. In our example, see, this is making the same structure. So if we want to find out theta, we can do a tan theta of O. So O is going to be the perpendicular height. Perpendicular height of this this triangle, and that is going to be 2 minus 1, right? So 2 minus 1, and that is divided by this length, and this length we can see 3 minus 2, 3 minus 2, and that is going to be 1 divided by 1. So tan theta is 1. So we know what tan theta is. Now we want to know what theta is going to be. So theta would be arctan, which is the inverse function, arctan of tan theta, this value. We know A, we know O, we know A. So we should be able to calculate arc10 as well. And arc10 is usually a part of all the libraries, all the language libraries. So for example, in JavaScript, we are provided with math.arc. Sorry, it is A10, I think. math.A10.2 and then y x. So with this thing clear, we can go to our drawing board and we can start coding. And okay, let me also give you a brief of the algorithm that we are going to follow. So first of all, we are going to calculate all the points which are same as our as the given location. So so that we can calculate at least the number of points, the least number of points that is always visible, and we'll initialize max with that point. Points at origin. Then second thing would be we'll calculate all the angles that all of these points are making with respect to the origin that we are given with. So from the list, we'll map it to the angles, and then we are going to sort this list of angles, right? So that means we would know this point comes before this point comes before this point, something like that. And after that, this is going to be a typical sliding window question. So let's say this is the sliding window, then we move the sliding window all around. All right, so let's go and start coding. Let us start with looping through all the points and making a list of angles there. So for that, we'll need an empty array of angles, and then we'll start with looping. So it is going to be the list of points, and from each point, let's take x and y coordinates. So x is going to be points I and 0, and let y is equal to points I and then x y coordinate. In case if it happens to be the x and y coordinate happens to be the origin, we should skip it. So if x is equal to location and y is equal to location 1, then add it to a list of points on center. So I'll call it on center, initial it is 0, and I increase it by 1. So at the end of when we are returning result, we'll be adding this on center there, and we're going to skip it from our list that we are going to build right after it, and then otherwise add it to list of angles. So it is going to be angles dot push, and I'll create a function and call it get angle, and it will be needing x and y and the location for reference, and the return value will be directly pushed to angles, and it is going to return angle. So let's quickly build the function get angle x comma y and then reference. We could call it origin as well. I think origin will be better. So we have already discussed about how to get angle. We are going to use inverse of tan theta to get theta, and tan theta because we have y and x, which is going to act like opposite side and adjacent side, in a triangle. So let opposite is equal to y minus origin 0. Let adjacent is equal to x minus, sorry, this is going to be 0 here and 1 here, right? And then we know that angle is going to be math dot a10 2. A10 2 is the function that we use for getting angle from tan theta. Opposite comma adjacent, and so this returns angle in terms of radians, and we'll need to convert that into degree, because this angle that you see here is going to be sent in degrees, so we should have the same unit everywhere. So in order to do it, we'll add it to multiply it by 180 and divide by pi. Yeah, and then we can return angle. There's just one quick thing that we should remember here. The angle that we get, this is the range is between minus pi and plus pi, and that's in radian that we have already converted into degrees. I think it will be better if we can just have a list of these angles in terms of degrees from 0 to 360. So convert it to 0 to 360 range. Yeah, and it is going to be quite easy. If angle that it calculated is 0, less than 0, then we just add 360 to the angle. And if this is not clear, let me quickly tell you with a diagram. So let's say this is our x coordinate, y coordinate, and pi is 0 to pi is in this region, and then minus pi to 0 is here. So if we want to convert all of these angles which are going to be in minus into their positive angles, what we can do is, let's say that there is some angle here, we add 360 degrees, so the value of the angle doesn't change, but the sign changes. Sign becomes from minus to plus, right? So I think that's easy. I hope you understood. So yeah, let's continue. Angle is there, return angle. Yeah, so I think this part is done, and we have already pushed all the angles here, so we already have a list of angles. Then what is left is, yeah, we can sort on the angles, and angles will be sorted according to the angles themselves, so it is nothing but just a simple numeric sort. So angles dot sort a comma b and a minus b. So this should sort in ascending order. Yeah. Now one more corner case that we need to take care of is that so again, this is going to be our graph, and we start searching from here like this. So this is the window that we take, and then we take a complete circle and we continue this until it reaches here, right? So in the beginning this is the portion, in the end this is the portion. Now see if there are some points which are going to be like this, then we should also take this theta in such a way that these points are also covered. But we are going to miss that in this current scenario. So these additional points should be added to the list of angles, and these should be added in such a way that the angle that they make with the center is not less than 360 but more than 360. So just to give you an example, let's say that this point is making an angle of 30 and this point is making an angle of 270. So in order to check whether they are in the same sliding window, it will be easier if we can make this 30 into 30 plus 360 in the second round. In the first round 30 is fine, but in the second round it should be 360. So what we are going to do is we are going to add all of these points, the angle that these points make with x-axis, and add it to our angles array in 30 plus 360 format. So angle plus 360 format. Yeah. So that's what we are going to do now. This is going to be easy. How to do that? So first of all, let us figure out what is the largest angle that our array of angles have. Largest angle is equal to angles dot length minus 1. So because angles is already sorted, the last angle of this array is going to be our largest angle, right? And let's also make a temporary list of these additional points that we are going to add. Let's loop through our angles array. And we need to continue this loop until the current angle plus 360 minus the largest angle, the value is going to be greater than angle. So while the value is less than or equal to angle, we'll continue the loop, and we'll stop the loop when the value of the current angle goes beyond the angle that is provided here. So if angles I plus 360 goes beyond angle, so angle, then we break the loop. Otherwise we add this to our to the temporary array that we have, 360, and then at the end just concatenate this with angles. So I think all the pre-processing is done. Now comes the meaty part, where we actually run the sliding window algorithm and figure out the maximum number of points that are covered by the given angle, right? So let max is equal to 0, and for let start is equal to 0 and is equal to 0. So we start with from the beginning itself, and we need to run it until end reaches the end of angles array, and n plus plus. And we need to increase start pointer when angles end minus angles start is more than angle, the given angle. That's when we increase start. And yeah, that's okay. And then we update the value of max, and value of max is going to be maximum of max itself, which is initialized at 0, and n plus 1 minus start. So this value here is going to tell us the size of the current sliding window. And at the end we just add max and on center both. On center is the value that we calculated in the very beginning, and these are the points which are at the center, at the location itself, the reference location itself. I think this should give us our answer. Let us try and run it. Oh, we got it. Let's try and submit it. Seems like the answer is not right. There is some error, is it? Angle send minus angle start. This looks okay. Angles dot concat temporary. This is also fine, I guess. Angles 360 more than angle. Yeah, this is also fine. Oh, I did not subtract the largest angle. Yep, that's the issue. Use the example test cases. Oh, one more. So this is when the angle submitted is going to be 0, and there are obviously two. Okay, so this was one problem. We have sorted the angles here. This looks okay. 0 to angles dot length I plus plus. Yeah, that's fine. Then here we are doing angles dot push with respect to location. Yeah, that's okay. X is location 0, Y is location 1. That's when we add to center. X is 0, Y is 1. What about get angle? X comma Y comma origin. Opposite is going to be Y minus origin 1. Yeah, X is going to be X. Oh, this was supposed to be minus. Yeah, this was accepted this time. That's all. Thank you so much.